first one? Right, we see the square root. We do not, I repeat, we do not say 18 divided by 2 because 18 is under the square root. We want to simplify that surd first. And how do we simplify the surd? You look for a square number. That was silence there. Crickets, crickets. You look for a square number that goes into 18. So what are our square numbers again? We got 4, we got 9, we got 16, we got 25. I could keep going, but I'm stopping right now because what square number goes into 18? That's right. So this now becomes root 9 times root 2 over 2. And what is the square root of 9? 3. So this is 3 root 2 all over 2, and that's as simple as it can get. You go no further. All right, in a moment you can go and check your calculator if you really want to. Okay, next one. If the question said factorize and solve, what is the first thing that we want to look for? Common factor. Fantastic. And what is our common factor here? 2x. Okay, so we pull out the 2x and we are left with right, 9 minus x equals 0, and we get x equals 0, x equals 9, making sure that you finish that off. Oui? That wasn't actually the question that I wanted to put there, right? I actually wanted to make it 18x minus 2x cubed. So how does that change things? Still got a common factor of 2x, do we agree? But what goes inside the bracket? 9 take x squared. Now that should be something that we recognise. 9 take x squared. It's a certain type of quadrille. Close, not a perfect square. It's the difference of two squares. So that would actually factorise to be 3 take x, 3 plus x. And so now my solutions are 0, positive, negative 3, because that's what fits in. So again, looking at the types. All good? All good? Okay, next one. We really hope that there's a common factor because we see the 5 there. But alas, poor Yorick. I did not know him well. So, if you wanted to go splitting the terms, you can. However, take 5 seconds to go 5x, x. What are the common factors of what are the factors of 21? So what numbers go into 21? 1 and 21, 2 doesn't, 3 and 7. Now, you're going to rule that out, aren't you? Although 21 and 5 won't give me 32. Are we looking? 32, we got 5. We really want to times it by 7, which means 5 times 7 has to go there. Agreed? And then the 3. If you were splitting the terms, you would still be working out what's 5 times 21. Positive, negative, because you've got 5 times 7 is positive 35. Take 3 gives you positive 32. Again, if those are the ones that you go, I still need help with those, see me. Or say, whack up a video if you want. Okay, and don't forget to solve. We're solving 5x take 3 equals 0. So the 3 goes on the other side, becomes positive. How do I get rid of it? Times 5? Divide by 5. And of course, we've also got minus 7. Who's got 3 from 3? Oof. One person has put their hand up. So pressure's on. Are you going to get 4 from 4? So the last one that we want to do, it's completing the square. We want to put it in this form. And I was a bit mean for first lesson of the week, but you know, bring it on. Who can explain what do we have to put in this bracket?
X plus 7 over 2.
Right, you divide this little sucker by 2. Okay, so it's x plus 7 over 2. We've got our take 3 there, but what we've actually done, when we expand this, you know you've got x squared. You'll get 2 lots of 7 over 2x. Right, so they cancel. That's how you get the 7x. And what else will you get at the end? This thing squared, isn't it? So you have actually added on 7 over 2 squared. You cannot add on the other side because it's not 0, it's y equals. So we're just going to fix this up by taking. So you've added in the 7 over 2 squared. If we take it off, no changes here. We haven't stuffed it up. Does that make sense? It still equals the same expression. So now I've got x plus 7 over 2 squared. Take 3. How do I square a fraction? Remember, no calculators. How do we square a fraction? Square the top, square the bottom. So I've got 49. 7 sevens are 49. 2 2s are 4. I want to try and simplify this. So sorry, but I know I can do this on my board. I'm going to rewrite 3. I better not. I'm going to rewrite 3 in terms of 4, just to make my life easier. So does everyone agree that that would be 12 over 4? So my brain is not overstrained. We good? And now what is minus 12 take 49? Oh, I've got to do 49, 59, 60, 61. Ooh, and there we go. What's the benefit of putting it in that form? Sorry, dear. I can easily find the vertex. So when it is in the form y equals a, x take h squared plus k, my vertex is hk. So if the question said hence state the vertex, I could now go minus 7 over 2 minus 61 over 4. Sweet? Starting. We should know a lot of this already about the vertex. Okay, we've discussed this in previous lessons, that the vertex, another word for vertex, TP, not toilet paper, but turning point. When we're looking at that convex quadratic, what would you call the vertex? What's another name? Minimum. If it was concave, we're talking maximum. Get used to that language. So one way to find, you don't have to write this down if you don't want to. If you want to, by all means, feel free. We average. So if I call one x-intercept p, the other one q, it's the average. Add them together, divide by 2, we can get our x value for the vertex. Agreed? If we complete the square and put it in this form that we've just talked about, bang, we can get the vertex. Agreed? But if it's a disgusting, so if I've got something like y equals minus 3x squared plus 8x plus 2, do you really want to be completing the square? No, you don't want to do that. I also don't even want to factorize to try and work out the average and whatever. I just want to use our formula. Have we seen? Yes, I've written on the board already a couple of times. This is our formula. We recognize the minus b on 2a because that's our axis of symmetry. This is just fancy pants notation for sub this value back into the original equation to get your y value. We've seen the b, we've seen the a, all groovy. Agreed? So if you need to, you are writing vertex formula. And we are going to use that. I can scroll up. We are going to use that to find the vertex. And you'll find it's quite nice because you've done worse when you've used the quad formula. We're going to consider completing the square. We're going to go x equals minus b over 2a. You've done this before with the quad formula, so it is. All right, We know our b is 8, so it's going to be minus 8 over 2 times a. Your a value is negative 3, so over minus 6. Make sure that you cancel. So you're not doing extra work. The negatives cancel, and I'm left with 4/3. Agreed? To get your y value, what we said, all right, this thing up here, that just means go back to your function, and wherever x is, you're going to replace it with 4/3. Calculator allowed, I would say. So we've got minus 3, and I'm going to run out of room here. 4/3 squared. Poor form by me. Sorry about that. But whack it in your calculator. Has someone already done it? What do we get? Okay, so we've just slapped that in. We've got our vertex. If I asked you to say, how many x-intercepts will this have? Will it have 2? Will it have 1? Will it have none? What could you do to answer that question? I don't want to find the x-intercepts. I just want to know, is there 1, 2, or none? What would you do? You would find the, yes, Lil? You would find the discriminant. And who remembers what is the discriminant? Gracie? What is the discriminant? B squared. Thanks, Dims. B squared minus 4AC. 2 minutes off. Right? So we have all of this knowledge. Now what we're going to do is put it all together. They're going to ask us to sketch the graphs. Okay? And those who are happily working are whispering. So if we're doing this, we look at that bit there, because we are going, yep, I'm going to divide this 2 by 1. So that becomes x minus 1 all squared. But we know when we have a perfect square, if you were to expand x minus 1 squared, you would get x squared. Going too fast? Take 2x plus 1. Do you agree with that? Yes? If you expand this, this is what you get. So writing x squared take 2x like this, you have actually added in an extra 1. So we have to take off that 1. And here's still our plus 3. Okay, so as the question has asked, we have now got it in this form. Right? Why does that help us? Well, now I can say, well, therefore, my vertex is, what's my vertex? Not minus 1, 1, 2. Okay? Reverse the sign, keep the sign. It's convex because it's a 1x squared there. You should also be able to just look at this equation right here and tell me, what is my y-intercept? 3. I like how we said that. 3. Right, we've got our y-intercept, which occurs when x is 0. 0 squared is 0, minus 2 times 0 is 0. So we've got 0. Oh, that looks like a 6. 0, 3. Huzzah? I'm now going, I want my x-intercepts as well. Right? If you, again, go back to this equation, you've got extra work to do. Where should you go to find your x-intercepts? You have just done all the hard work here. If we now go 0, because your x-intercept occurs when y is 0, correct? If I now go 0 equals x minus 1 squared plus 2, you now want to solve for x. So how are you going to solve for that? You don't want to expand. You just want to get x by itself. So can we get rid of the plus 2? Yep, we take 2, and I don't have to go any further because my next statement will be what? Pardon? No. Ads just says no. No x-intercepts. Why? Wait, I'm coming to you. Why have we gone no?
Because you can't square root a negative number.
Exactly. Everyone hear that? Because my next step would be, get rid of this squared, I'm going to square root. We cannot square root a negative number. Now this doesn't mean the graph doesn't exist. Wait for that. It means what?
Doesn't go through the x axis.
Absolutely spot on. So we've got 1, 2. We've got an x-intercept here of 3. And it's sitting totally above, and we've justified that. Does that make sense? Okay, let's try the next one. And yes, we're overachieving. We're going to find the y-intercept. We're going to find the x-intercept. So, sorry, we just went through and we're doing this one. All right, we divided by 2. But when we expand this, we ended up with a plus 2 squared, so we took it off, yada, yada, yada. We're at the, find the x-intercept. We said we could have gone back up here, but then you're using the quad formula. Extra work, wouldn't be wrong, but you're just doing extra work, tick-tock, in a test or assignment or homework. We've already got it here in this form, so I'm going to make that equal to 0. I got my minus 6 on the other side by plusing 6. I got rid of this squared by square rooting, but I said I have forgotten something. What is it? Yeah, roots what? Plus or minus. Well done. You've got to have the plus or minus. And now to get rid of the plus 2, we take 2. Okay? So those are my 2 roots. We're now going to sketch the sucker. Oh. Okay, are we concave or convex? Convex, positive. Okay, so minus 2, minus 6, minus 2. I've even put my axis of symmetry down to help me sketch it, so I know I'm going to be nice and symmetrical around it. Okay, do I know what minus 2 take root 6 is? No, somewhere there. This will be somewhere here. And I try, oh no. Oh, still stuffed up, right? So this is the best way to do it. Go through your x-intercepts and go, oops, that's minus 2, and now this is minus 6, right? If you try and connect through every single dot when it's not to scale, it's going to be so hard. Don't forget y, x. Here we go. Number 1, state the axis of symmetry. Yeah, man. No consultation, no having to look stuff up because we know this now. It's minus b over 2a. What is my b value? So minus 5? 5. 2 times a. 2 times 2. We are done here. Right? Is there a number that goes into 5 and 4 apart from 1? No. Done. Thank you for coming. Okay, part 2. Find the vertex. So what we have at the moment is we have our vertex is 5, 4, but we do not know our y value. Well, how do we find our y value? When we have sub. Right, so we're going to sub it. Right, we're going to say 2. As a teacher, one of the most frustrating things is when you're marking work and students will get the x value and then they go, I don't know how to get the y value. Seriously? That's when my dogs used to run out the room because I'd go, oh my God! I'd yell and they'd run. No. Okay, so it's minus 9 over 8. We've got our vertex done. right? Find the axis intercepts. How are we going to do that? S'il vous plaît. Taj Magaj, you're chewing gum in my class. Please put that in the bin. Okay, how am I going to find the x-intercepts? Kabi? Axis intercepts. Give me one. Take the easy option. Your y-intercept is your easy option. Let's just add it on 2 minutes. Okay, so find the axis intercept. That means you've got to find your y-intercept. You've got to find your x-intercept. You don't, because I will remember. Okay, so 0, 0, and therefore we've got 0, 2. But you've now got to get your x-intercepts. To find your x-intercepts, we're making y 0. So we're solving 0 equals 2x squared. Take 5x plus 2. At this point, you've got some decisions to make. You have to solve a quadratic. So how can we solve a quad? What are the ways? Let me count them. Let me count the ways. Factorize. What's the other way? Complete the square. No way, Jose. Quadratic formula. What's another way? Discriminant could tell us how many roots we have. Very good, right? But collator. Now, if we were in the non-calculator component of our test, or our calculator is just too far away, we do this. It's very disconcerting again. We do this. And I would appreciate if you actually listened to this. There's no common factor, right? The reason I'm actually trying to factorize is because what are 2 2s? 4, and I put a 1, so 2 and 1, I could get 5 possibly. So 1, 2. Now when I times them together, I get a positive answer, but when I add them, it's minus. So they're either both positive, which wouldn't help me with this, or they're both negative, and lo and behold, 2x times 2 is minus 4x, take 1 is minus 5x. I'm factorized in the space of 5 seconds. If you can't do that, you are then doing the quad formula. Tick tock, tick tock, tick tock. So that's why it's important to practice factorizing. If you want to do split the terms, go for it. Okay, so we've got our vertex, we've got our axis of symmetry, we've got our y-intercept, we've got our x-intercepts. We now have to sketch the graph. So we ask ourselves that age-old question, is it concave or is it convex? Convex. So you get a ruler, get a nice ruler. What was my vertex? A bit minus. Right, positive, 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 positive. So I'm not going to have it even Stevens. I'm going to lean a little bit to the right. Yes? Vertex is a little bit down, so I'm going to do this. I'm going to go nice. I'm just going to fill in my shapes now. So what was that? That was 2. This was a half. This was 2. This was x equals 5 over 4, and your vertex is 5 over 4 minus 9 over 8. Bang, done. And I'm not still spending ages on a question. Short, sharp, shiny. Now, Piper, you don't label your axis, right? So graphing questions in a test probably going to be worth about 3 marks. So finding all of this information, you get marks for that. But then actually sketching the graph, they can be about 3 marks. And it's not 1 mark here, 1 mark here, 1 mark, it's 3. I will take a mark off if it's not symmetrical. So if it looks really wonky, mark gone. If you don't label your axes, mark gone. My big bugbear is that you don't label your axis of symmetry. Make sure that is there. Okay? So you did really well. Can you please make sure that you practice the rest of those, making sure that you can sketch graphs really well. Tomorrow, we'll go through any questions you have with that, but then your investigation.